So here is the plan. As we're going to kind of jump right back in. We're still in chapter 9, but we're going to separate this from the other stuff. So this is kind of its own unit. We're going to talk about what are called polar coordinates today. And for about the next 2 weeks, basically this week and next week is kind of going to focus on polar coordinates and polar graphing and all that kind of stuff. Number one focus of today is trying to understand how polar coordinates are related to what are called rectangular coordinates, what you're normally used to. And just kind of getting the idea of what's going on. Like I said, this will take us about 2 weeks, I think. And then we're going to start getting into that introduction. I told you at the end of the year we're going to kind of introduce some concepts in calculus. And that's where we're going to kind of start the introduction is in a couple of weeks. So we'll get into that and we'll go from there. Okay? So here we go. Polar coordinates. Number one thing, rectangular versus polar. Rectangular is what you're normally used to. So for example, if I put this up here, when you plot a point in rectangular coordinates, from the origin you always go over a certain amount x and then up a certain amount y, and that's where your coordinates are plotted. What we are going to do is talk about a different way of plotting coordinates that are called polar coordinates. Here's the difference, okay? So instead of going left or right and then up or down to get to that point, what we're going to do instead is we're going to kind of think of it as a circle, okay? If I were to draw this in, what we are looking at is this. It's kind of related back to the unit circle is the idea. So let's say that that's the circle that we were going to plot that same point. This then would be your radius, okay? The radius of that circle. And just like when you plot a point in rectangular, you need two things. You need an x-coordinate and a y-coordinate. You need two parts when you're plotting things in polar coordinates as well. You need to know the radius. How close to the center of the circle are you actually plotting the point? Okay, obviously the bigger the radius, the further you are away from the center. And then the second thing is, we're going to look back at that value being theta again. You need to know at what angle are you working your way around the circle. Okay, how far, again, like I said, very similar to what you did when you talked about the unit circle. Okay, so you need a radius and you need theta when you're plotting points. And I'm going to give you, over break, I put together kind of some polar coordinate graph paper for you that I'll give you. Here's the general idea what it looks like. Now, this is way more than what you're going to have. But the idea is this. If you notice, these are just a whole bunch of what are called concentric circles, just circles inside of circles. Okay? And the idea is we're going to figure out at what angle, like I could go through and I could plot a point right there. That would be, if we're kind of following this idea, there is the angle that we're talking about. There's the theta. And then if you were to count all these different rings, if you will, almost like it's a tree, that's the radius, how far away you are from that center. Now, we're not going to go this complicated. We're not going to deal with a radius in terms of 15, 20, something like that. We're going to take a bunch of that stuff out and kind of narrow it down to that. Same concept. Okay. Like I said, maybe I plot this point right there. Well, in that case, you went, if that's your value of theta, you went that angle, okay, that degree measure. And in this case, you went 1, 2, 3. This would have a radius of 4 because you are 4 out from the center. Okay, is the idea. If I were going to compare that to rectangular coordinates, normally what you would be doing is you would be going over a certain amount and then up that corresponding part. Same idea, okay? Like I said, same concept as a unit circle. So, if you don't have it, why don't you take out your unit circle? You're going to want it today. You're going to kind of refer to that. So pull that back out. We're going to reference this a few times. So, like I said, we're going to reference our unit circle. We're going to come back to this. Most of the angles that we talk about, most of the thetas that we're going to talk about today, will be the unit circle angles. Not all of them, but most of them. That's why I'm having you take this out. Okay? So, here's the general idea. Here's kind of your background information. So if x and y are rectangular coordinates, you need x and y. Like we said, r and theta are your polar coordinates. With r being the distance from the pole, basically being the radius, if you will. How far away from the origin are you? And theta is the angle at which you're going. Right? We kind of talked about that already. So that's just summarizing what we're getting into. Here's the exact idea that we just talked about, but not on the actual polar graph paper. Okay? If your polar axis is like your x-axis, you're just going a certain angle and a certain distance. Okay? Radius and theta is what we're looking at. Just a quick heads up. So here's what this is referring to when you take a look at the bottom part. And we'll come back to this a little bit later on. But when you go through and you deal with r and theta, if you remember back to the idea of coterminal angles, all the first part is saying, all the top one is saying where it says non-uniqueness, you could go r theta and you could plot a point. Or you could go around the circle again, another 2 pi, and another 2 pi, and another 2 pi. There's a lot of ways, there's a lot of points that could end up if we just keep adding or subtracting 2 pi. That's all that's saying. What we're going to do, though, in general, is we're going to stay within 0 and 2 pi so that you don't end up having to keep going around and around and around. Okay? The other option is this. Notice where I say go backwards on this one. We could go to theta, okay, whatever theta is, and then let's say we add pi, or 180 degrees. That puts us in the opposite quadrant. If you notice, then r is negative. It's not saying that the radius is a negative number. It's saying that you're going in a negative direction. So you're going in the opposite direction. We'll take a look at that when we get into the actual plotting of points. Okay? So if I were, matter of fact, let me show you a little bit right here. So for example, if you take a look at these points, these are all the same point on the polar coordinates, on the polar grid. So for example, if I have 1 and negative pi over 4. Negative pi over 4, first off, by the way, is what in degrees? Pi over 4 is what in degrees? Let's put it that way. 45 degrees. So we're going to negative 45 degrees with a radius of 1. That's what these coordinates say. Which means we are down here someplace. Okay? Somewhere in that vicinity. There's your radius of 1. That's your theta right there. Okay? If you take a look at the next coordinate, okay? If you take a look at this next coordinate right here, it's the same ending spot. Again, just like unit circle. Radius of 1, but instead of going a negative pi over 4, you're now going in the opposite direction, a positive 7 pi over 4. So you're actually going that direction. So another way to describe the same point. Okay? Just a different direction to get there. Now if you take a look at the next one, here's where you need to make sure you're paying attention and make sure you're understanding this. Because notice, now the radius is negative. But again, that negative just says you're going in the opposite direction. Where is 3 pi over 4 in the unit circle? Where is it? Which quadrant are we in? We're in quadrant 2. It's the 45-degree angle in quadrant 2. So what this point is really saying is, if I go 3 pi over 4, that's that value. Okay. That would be that point. But because it's a negative 1, instead of going in that direction, we go the opposite direction and we end up in the same spot. Okay. We're not going the positive direction to 3 pi over 4. We're going the negative direction, and then we therefore end up in the exact same spot. Okay. And so same idea with negative 5 pi over 4. It's the opposite direction twice. Okay? And we'll get into that as we work our way through some examples. But for now, I just want you to understand that there's different ways to get to the same point. Okay? Depending on the radius, depending on the angle. All right. So number 1, if you're starting with polar coordinates, if you are given polar coordinates and you're trying to get back to rectangular, x and y, meaning if you're starting in polar coordinates, that means you know the radius and you know theta. You've got those two pieces. We need to work our way back to rectangular form. I need to figure out what's the x coordinate that goes with this and what's the y coordinate. So here's the idea behind it. from that picture that we started with, now I took out the circle and all that stuff. There's our triangle that we're dealing with. What's the cosine of theta in that picture? What over what? Okay, adjacent. Remember, cosine is adjacent over hypotenuse. So it is x over r. So the cosine of theta in that picture is the ratio of x to r. What about the sine of theta? It's y over r. And so ultimately, when we go through and we take care of this, what we are doing, remember, we're trying to get back to x and y, which means, here's where it's coming from. If you just solve that equation, if you just multiply both sides by r to get x by itself, that means x is really just r times the cosine of theta. The y-coordinate is really just r times the sine of theta. And remember, since we're starting in polar coordinates, you'll already know r and theta. All you have to do is plug them in and find the x-coordinate. All you have to do is plug it in and find the y-coordinate. Okay? But this is just coming from right triangle trigonometry. I wanted you to understand the background behind it. Okay? All right, let's do an example so you can kind of see. Let's put it together so far so you can kind of see it at work. So example number 1, we're going to plot this point, and then we're going to change that into the rectangular coordinates rather than the polar coordinates. Let's start with plotting the point. First question, what is pi over 3 in terms of degrees? Yeah, that's just 60 degrees is all that is. I'm going to put that in there. That's 60 degrees. So we're going to plot a point that is at a 60-degree angle that has a radius of 5. There's 5 units from the origin. So in this case, when we do that, we go to our 60 degrees and we just count out 5 from the center. So here is 1, 2, 3, 4, 5. There's the point right there. 5 comma pi over 3 is that point on our polar grid. And I did for your assignment today, when you go through and you're doing some of these problems, I put together like a polar graph paper grid for you, and I attached it to your assignment. So you have this. You won't have to worry about like trying to create this or something along those lines. So there's the actual point that was given. And now the question is, what's the corresponding, if I wanted to think about this in terms of x and y, and let's say I wanted to figure out what that x value and what that y value were if this was a rectangular grid instead. That's where our equations are going to come into play. But, like I said, we already know r and we already know theta, so let's plug them in. So x equals, our radius we said was 5, we can plug that in, times the cosine of pi over 3. We already knew our theta as well. Or 60 degrees if you want to do that, that's fine. Same thing with y. Radius of 5 times the sine of pi over 3. And now we just get some answers. Okay, what is the actual x-coordinate of that? What's the actual y-coordinate of that? First question, what's the cosine of pi over 3? Here's why I had you take out your unit circle. 5 times cosine of pi over 3 is 1/2, which means the x-coordinate of this point in rectangular form is 5/2, okay, or 2.5. Then if we find the corresponding y-coordinate, what's the sine of pi over 3? Square root of 3 over 2. So we've got 5 times the square root of 3 over 2. And this one I'm just going to kind of clean up a little bit. I'm not going to multiply it out. I'm just going to leave it as a fraction, leave the square root. That means the y-coordinate of that point is 5 times the square root of 3 all over 2. Maybe. There we go. And so here's the coordinate in polar form. The corresponding coordinate in xy form would be 5/2, comma, 5 square root of 3 over 2. There's the actual coordinates if you were to plot this on the x and y axis like normal. Okay. Number one goal for today, for everything we do, is one, just getting familiar with what are polar coordinates and what do they do, and then just working your way back and forth between the two. Okay, relating polar form to rectangular form, what you're used to. Okay? That is the goal. That is the main idea for today. Just kind of getting used to that and working back and forth. Okay? Any questions on this one? Any questions on graphing, converting it, the coordinates back? Like I said, for the most part, it's just using formulas. Okay? All right, let's do another one. Let's take a look at example 2. This one's a little bit more complicated only because of the fact that now we've got a negative radius and a negative angle measure. So first off, let's plot the point on the polar grid here, and then we'll figure out what the corresponding value is in rectangular form. First question, where is negative 3 pi over 4? Let's start with the angle first, and then we'll work with the radius. What is it? It's the same thing as a positive 5 pi over 4. So therefore, that means, which is 225. So this is normally where you would go. You would go to that angle right there. That would be your theta. That's negative 3 pi over 4. But because the radius is negative, instead of coming this direction, we're going to go in the opposite direction to which angle? We're going to be going to 45 with a radius of 1. Okay? Whenever that radius is negative, you just go in the opposite direction. Okay? So, right, we've got a radius of 1 at 45 degrees. There is the actual point that we just plotted. Okay? It is in the first quadrant. So it's the same thing as a radius of 1 and a theta value of pi over 4 or 45 degrees. Let me stop for a second. Any questions on that? Because I know there's multiple things going on on that one. Always start with your angle and then figure out your radius after that, like where you're headed. Okay, so now if we go through and we plug in our values, now let's actually figure out what's the corresponding x and y coordinate of that point. Okay, so if we plug in the information again, radius we said was negative 1 times the cosine of negative 3 pi over 4. So remember negative 3 pi over 4, that was down here at 225. We're using those coordinates. What's the cosine of negative 3 pi over 4? It's negative square root of 2 over 2. Okay, so we get negative 1 times negative square root of 2 over 2. And therefore, the x coordinate of our final point here is the square root of 2 over 2. Okay. What's the sine of negative 3 pi over 4? Also negative square root of 2 over 2. Which, once again, when we multiply by the negative 1, we end up with a y coordinate of the positive square root of 2 over 2. So in this case, our point is actually the square root of 2 over 2 comma square root of 2 over 2. Quick question for you. Let's see if this makes some sense. Remember the point we plotted? It's that point that was in the first quadrant at 45 degrees. Anybody tell me why this should make sense? Think on your unit circle. Isn't it a circle of unit 1? We have a radius of 1. There's your coordinates at 45 degrees right there. Matches up with, in this case, the polar coordinates that you were given. Okay? So just trying to make that connection, making sure that you see that that's the same thing. Okay? How we doing, okay? All right, try the next one on your own. Try example 3, see what you got. 0, negative pi. It's a little bit tricky only because of the 0, but give it a shot. I'll give you a minute or two here to see what you can come up with. Plot the point and then find the xy coordinates. Should all make sense when you're done. Don't overthink this one. Is what I'll tell you. I hear a lot of discussion on. Don't overthink this one. And when you find the x and the y coordinates, it should confirm what you're thinking. All right, let's take a look. So my angle is negative pi, meaning I'm going in the opposite direction. So we would normally go that way. But then I've got a radius of 0 in this case, which means where am I at? We're at the origin, basically. The reason why these are called polar coordinates is our starting point is what's called the pole. That's why it's called polar coordinates. But it's the same concept as the origin. So because we have a radius of 0, there's your point that you plotted. Okay? If it was a radius of 1, we would come out 1. Radius of 2, radius of 3, we would be out here. If it was anything other than 0. Which means, by the way, what are the coordinates? What are the xy coordinates? Yeah, if you think about it, it should be 0, 0, right? Let's just confirm just to make sure. Okay? If we plug in the information that I already know, x equals radius of 0 times the cosine of negative pi. What's 0 times the cosine of negative pi? 0. There's your x coordinate of 0. I don't even care what the cosine of negative pi is. Since it's multiplied by 0, the answer is 0. Same concept with y. 0 times the sine of negative pi. Same thing, you end up with a y coordinate of 0 as well. Like I said, confirming what you really already knew. That point is really just the origin. It is the point 0, 0. Okay. All right, how are we doing on that? Okay? Fairly straightforward. All right, let's keep going. So that's if you start in polar coordinates and you're going to rectangular, back to what you're used to. The other option, the other thing we're going to look at today is the other way. What if you're in rectangular coordinates like you're used to, and I need to switch it to polar coordinates? So if you take a look, here's how we convert the opposite direction. So that means you're going to be given a point, x, y, and you're going to convert to polar form, meaning you need the radius. You need to find what is r and what is theta. Those are the two pieces you need anytime you're in polar form. So once again, if we go back to that triangle that we started with, this x squared plus y squared equals r squared. Let me go back to that slide. Is coming from right there. It's just the Pythagorean theorem. X squared plus y squared equals r squared. It's just, that's the equation we're going to use to find r. Because remember, if you're in rectangular form, you already know x and y. And therefore, you can just basically plug it in, do the Pythagorean theorem, and you've got your answer. The other part, let me go back to our problem here. To find theta, most of the problems today are unit circle problems. So we're going to go through and we're going to be using the unit circle. Tangent of theta equals y over x. That is also coming from the same picture. It's just the ratio, opposite over adjacent, y over x. Y coordinate over x coordinate, which, like I said, you already have. You're going to start with that. Okay? So let's go through an example of how we work our way through that. So in this case, here's your starting point. Here's your actual xy coordinate, if you were to plot it. 3, negative 3 square root of 3. We need two things to get it back into polar, r and theta. Let's start with r. So we've got x squared plus y squared equal to the radius squared. Okay. We're just using that formula from up above, which, like I said, is just coming from that triangle. And this we can do in our head. We'll figure this part out here. If we go through and we take a look at that then, 3 squared gives me 9 plus, oops, I forgot the squared on this one. There we go. If I square that, what's in parentheses, what do I get? There's a couple of parts to it. What is it?
27.
Should be 27. Where did that come from?
You get rid of the square root, and then you just get 9 in the first number.
Yeah.
And then I multiplied the 9 by 3 and 27.
You're basically squaring each part. You're squaring the negative 3. Negative 3 squared is 9. And then you're squaring the square root of 3, which is 3. 9 times 3 gives you 27. Okay? So this is really just 27 So what we end up with then is r squared equals 36, which means r is what? 6. There's your radius. We found that. Now we need to figure out what theta is. And that's going to come from this formula, the tangent of theta equals y over x. Because once again, you've got x and y. So if we set that up, tangent of theta equals y coordinate, negative 3 square root of 3, over the x coordinate, which in this case is 3. We can simplify that a little bit. Okay, the 3's will cancel, which means we end up with the negative square root of 3. Oops, tangent of theta. And now you go back to your unit circle again, because that is a unit circle value. And if we take a look, where does the tangent equal negative square root of 3? If I go back, oops, there it is. Here's one of them right here, negative square root of 3. So that's at 120 degrees, or 2 pi over 3. Just a quick heads up, by the way, I don't really care whether you use degree or radians, but your assignment today, I think all the answers that are provided are in radians, just so you know. So when you're checking your answers, be looking for the radian version of the angle. But I don't really care if you put it as like 120 degrees, that's fine. What was the other one? Negative square root of 3, where's the other one at? Yeah, 300 degrees down here. Okay, which is, oops. Let me move that back. There we go. Like I said, here's the other part that's at 300 degrees. So the question then becomes, well, which one of those is the right answer? Is it the 120 or is it the 300? And if we go back to our problem and we take a look, which one is it? Anybody tell me which one is, whether it's the 120 or the 300, and why? Why? Think about where, if you were plotting this point, think about what quadrant you're in. If you just plotted an x, you'd have positive x, negative y, which means you're in the 4th quadrant. Therefore, that's the angle that we need to use. Okay? So you're just working your way off of, if this is the actual point in xy form, okay, rectangular form, you got to make sure you use the angle that goes with that. So in this case, we're going to use the 300 degree angle. Okay? Theta is 300 degrees, or like I said, the radian version as well. Either one is fine. And so our final answer, our answer in polar coordinates would be 6, 300 degrees. There's the same coordinates in polar form. Okay? How we doing? Okay? Still doing okay, hopefully? All right. Try this one on your own. Try example 5 here on your own. And then we're going to do example 6 together, and that's the it. That's the end. Try example 5. Given the rectangular coordinates, find r, find theta, and write it as a polar coordinates. All right, so if we take a look, here's what you should have come up with. Should have found that the radius on this one, if you're just basically using the formula like I said, you get the square root of 8, or if you reduce it, it's 2 square root of 2. Okay, so there's the radius that you're using in polar coordinates. Quick question. When you plug in your y and your x, 135 degrees or 315? Why is it 135 and not 315? Yeah, negative 2, 2. If you're plotting that point, you're in quadrant 2, which means you use the angle that's in quadrant 2 that matches up with that. Okay, so in this case, it is not the 315, it's the 135 degree angle that we're talking about. Okay, doing okay so far? All right, last set of examples here. Now if we wanted to take a look and we wanted to write, this is kind of what I was talking about at the beginning. If we wanted to come up with more than one point, or more than one way to describe the same point. Okay? First, similar to what we just did, I want to change this into polar form first. Okay? First question, let's see if you can do this off the top of your head. What's the radius? Yeah, it's 5 if you think about it. Because if you were to plot that point, 0, negative 5, you're just going down 5. So your radius is really just 5. Now, if you wanted to still plug it in, the x squared plus y squared, you end up with 0 squared plus negative 5 squared equal to r squared. Well, 0 squared, that's nothing. That goes away. And you end up with a radius, in this case, of 5. Okay? If you do the math on that one, you get a radius of 5. So there's the first part. We know that we have a radius of 5. And if I were to plug this into that tangent formula to find the theta that goes with it, tangent of theta equals y over x. Negative 5 over 0. What does negative 5 over 0 equal? Undefined. Okay? That does not mean we do not have an angle. What that means is, where is the tangent undefined? You're looking for the angle where the tangent is undefined. That's what we're looking for on this one. That's why I wanted to take a look at that. So in this case, if you look at where the tangent is undefined, what are the two options? If I go back to my unit circle here a second. Pi over 2 or 3 pi over 2. Which one's the right answer in this problem? The 3 pi over 2. Because we're plotting the point 0, negative 5. We're going down 5. Okay? We're on the y-axis, but down on the bottom. Which means theta in this case is 3 pi over 2. Okay? So in this scenario, here's the corresponding polar coordinates right here. Radius of 5, 3 pi over 2 is the theta. And here's the other part then. Now if we try to find another point that has the same thing. And like I said, this is what I was going back to before. Let's say that instead the 3 pi over 2, let's say I actually did use the pi over 2, that other angle. So let's put that in here. That's the angle that I used. What would I have to change about the radius then? Then we just make the radius negative. This would become a negative 5, comma pi over 2. Okay? So you go up to pi over 2, but then because the radius is negative, you're actually going down instead of up. Okay? So those 2 points are exactly the same. Okay. All right, one last example, because there's something that happens on this example that you have not seen yet, and I want to make sure you understand how to do it. First part, let's find the radius. Okay? Same thing. By the way, when you plot the points 5 and 12, are these on the unit circle? Are these unit circle points? No. Okay, which means I'm going to kind of draw the triangle over here. If this is our theta, here's the x coordinate, there's the y coordinate. 5, 12 in order to get to that point right there. Which means, by the way, what's the radius? 13. It's a 5, 12, 13 Pythagorean triple. So we know that our radius is 13. How do I find theta on this one? Tangent of theta equals y coordinate over x, so 12 over 5. And unfortunately, 12 fifths, you're not going to be able to go on in the unit circle and find that. So what do we do instead? What have you always done before? Inverse tangent. You use the calculator on this one. Okay? And that's the only reason I wanted you to see this one is you you use the calculator and you use the inverse tangent when you're not on the unit circle, okay? As you go through and you do that, keep in mind that whatever mode you're in is how you, if you want the answer to be in degrees, make sure you're in degree mode on your calculator. If you want the answer to be in radians, make sure you're in radian mode, okay? Now, it's not going to give you, pi, in terms of pi, it's going to give you a decimal. So in this case, I would say, like I said, I think the answers on the assignment are going to be in radians. I don't really care whether you put the answers in degrees or otherwise. I'm going to do this one in degrees just because I think it'll make more sense. What do you get? What is that angle? I think it's 60 something. 67.38. All right, so there's your approximate angle measure that we have there. Okay. And now if I wanted to come up with a different way of coming up with that same point, let's say we change the radius to be a negative 13. What would I have to do to find the angle measure then? There's a couple ways you could do it. If that's a 67 degree angle approximately, how do I find the one that's opposite that? What'd you do? Just add 180. That'll get you from quadrant 1 to quadrant 3, but then you go the opposite way since I made the 13 negative. So if I add 180 to that, what do we get? 247? Yeah, 47.38 degrees. So you could go to the third quadrant, but then go the opposite direction to put you back in the first quadrant. Like I said, number one goal of today, just kind of getting used to these idea of polar coordinates and what are polar, working back and forth between polar versus rectangular, what you've been used to forever. Tomorrow, what we're going to do, we'll look at polar versus rectangular equations and kind of same thing, but with equations versus coordinates. Okay, and we'll work our way between those two. I do have an assignment for you. When I get you the assignment, make sure that you either circle the problems or write this down because it's not all of them. A lot of these are very, very, very quick. Okay, and like I said, I did attach to the assignment an actual like polar graph paper. So when you're plotting these points, which is some of that, that's all you have to do. On a few of these problems, it's just plot the point. So it should take you 10 seconds, not even that. Okay, let me get this out to you, and you've got just a few minutes left here.